Folks, hello. I thought I would do a couple more of these simulation problems for you here to close out week 8. What I'm doing the tire problem. I forget the number, maybe 1603, and then the Strassel bids. I believe it's 1615, but check my numbers on this. But the problems will be clear when you get into the homework. And just a quick overview on this. The tire company has put out a new model of tire. They've got a bunch of data. Looks like the average tread wear per tire is about 36,500 miles, excuse me, with a standard deviation of 5,000 miles. And what they know about this distribution is that it's normally distributed. So to estimate the expected wear on a set of tires, what I did, excuse me, is I used this norm.inv rand syntax that I believe I've introduced in another video. If not, it's in the book. So what this does, norm.inv, and then a random selection from a normal distribution with a mean of 36,500, which is cell C4, and a standard deviation of 5,000 miles. And that will return a value from that distribution. So if I hit F9 a few times, you see that that is going to change. What I've done is I've simulated that tire wear or expected wear 1,000 times, and you can see that in the column. I'm not going to go all the way down. The big thing here is if the set of tires has or wears out before 30,000 miles, the company is going to pay, or they're going to pay out based on increments of 100 miles under 30,000 miles. So for instance, if you got 29,900 miles out of a set of tires, you get $1 per tire, so you get $4. So what I've done to compute this is I've basically just compared each simulated value to $30,000. If the value is greater than $30,000, then you'll see 0 here because there is no cost. In the cells where the value is less than $30,000, what we're computing there is the difference between $30,000 in this value, and we're dividing it by 100. But you'll see that the syntax for the entire column D is right here. So you can make sure you take a look at that. And then, so there's 2 questions here that I'm going to help you with. Part A is, what is the average cost or expected cost per set of tires? And that's being computed here by, I believe I have the average and divided by 100 down in cell D1014. So you could take a look at that. So let's answer this one first. So if I hit F9 a couple times, you're going to see that this number is going to jump around. And so what you might want to do here, there's an easier way to do this in the bids problem because I don't have, I'm not using a data table in there. So I can use a data table to do this. So what you might want to do just for the heck of it to kind of play around with this is run the simulation about 10 or 15 times and then take the average of this value. And you should get pretty close to what Cengage wants. So 2.18 here. 2.50, 2.13, 1.92, 2.02, 2.45, 2.20. And just as a reminder, I'm looking at this value every time I hit enter, and that's what I'm recording here. So 2.68, 2.18, 2.06. Let me just do like 3 more here. 1.99, 2.43, and 2.28. And let's see what we get for an average here. We'll average these up, and we should be pretty close to what Cengage wants you to have. 2.23, $2.23. So I think the value that, and I can't remember if this is algorithmic or not. I think the value that I looked at was about 2.28. So as long as you're in this ballpark, that should be fine. If you get marked off, let me know and I'll fix your grade. The probability of, so what's the probability of making a payout of more than $50? So again, just a logic statement here. If this value is greater than 50, then I'll put a 1 in this column. Otherwise, I will not. So let's just make sure we got 1 in here somewhere. We do right here. So this payout's $57. So the logic statement puts a 1 here. And what I did down in, let's see, column E down at probably 1020 is I summed up all of those, all of the ones and divided it by 1,000. So the probability of a $50 payout here is about 0.6%. But similar to what I just did here, let me just throw a few of these together here and let's see what we come up with. 0.006, 0.008, 0.007, 0.010. I'm going to do these at 3 decimal places. 0.012, 0.002. It's pretty low. 0.009, 0.010, 0.010, 0.014, 0.018. It'd help if I could type. 0.008, 0.008 again, 0.015, and let's just see. Let's take an average here, see what we get. So the average of these values, so about 0.01. I think the value that Cengage wanted was 0.011. So again, as long as you can run the simulation and you're in that ballpark, that should be just fine. And again, if you lose points if you're off by, you know, a tenth or 100, just let me know and I can fix the bid, or fix the bid. I'm looking at bids, I can fix the grade. But let's take a look at this bids problem. So this is this company Strassel. They've got their eyes on a property. They think they can sell it for 160. What they're willing to bid is 130 for the property. And let me move that out of the way. What they do know is that there's 2 other companies that are bidding on the property. And what they know additionally is that each company is going to bid somewhere between $100,000 and $150,000, and that's a uniform distribution, meaning any value between $100,000 and $150,000 is equally likely. So what we're going to do here, let me get this out. I made sure I could do this. Because I want to show you how that works. So what I did here, I don't have a data table here. What I've got is I've got this neat little Excel function, RAND between. So RAND-BETWEEN, and then D8 and D9. So what I'm saying or asking in Excel for is a number between $100,000 and $150,000 and just return that. And so I've done that for bidder 1 and for bidder 2. So if we look at this particular bid scenario here, Strassel only wins the bid if they are higher bidder, or bidding the 130K exceeds both of these bids. And what you notice here is that this company bid 147.5. So in that case, Strassel doesn't win. But the logic here is what's called an if-and statement. So basically 2 things. You can take a look at the syntax. What I'm doing is I'm comparing this value to 130. I'm comparing this value to 130. If both of these values are less than 130, then what you'll see is a 1 in the logic column. If one or both are greater than 130, then what you'll see in the logic column is a 0, which means Strassel didn't win the bid. So for example, let me just hit the F9 key a couple times here. And let's just cycle this. Let's see, notice here that in this first simulation, they bid bidder 1, 112, bidder 2, 116. So in that case, the Strassel bid of 130 wins. So you can go down if you just want to make sure Excel's doing the right thing. You can do all that and make sure that they're playing the right way. So if I go all the way to the H column, what I have done down there is I have added up all the ones. So it looks like 349 in order to get a percentage. Obviously, we divide that by, let's see, I think we divided that by 1,000 bids. So the probability of win in this particular sim is about 34.9%. But since I don't have a data table, I can run this fairly nicely and come up with something, again, because this is going to bounce around if you hit F9. And obviously, the first time you get it, you're not going to get what Cengage wants. But here's how you can get back at Cengage right here. You can just show them that you figured out how to simulate their little value here. Let's do this, I don't know, let's do this 24, 25 times since it's this easy. So just highlight that and we'll put a data table in here. Since we just want to replicate that value, any input, just make sure they're not the same column. And then this should replicate. And then we've got one up on Cengage here. So let's get an average. Hopefully, I think this is about 0.36. So let's see if we can get somewhere pretty close to 0.36, and that would make everybody happy, I think. let's see if we get to point, yeah, 0.36. So even if we round that to, let's see, yeah, if we round that to 3 decimal places, we're at 36%. So the probability of win at 130K is 36%. And I think, so there's some other games that you can play around with here. There's a couple other questions that you need to answer. The one that says, what's the probability? I forget, I should have the question open, but I just want to get you started. There's a question of what do they have to bid to ensure a win? I think you can figure this out that, obviously if they bid 150, they're going to win. But if you play around with this cell right here, the simulation will update because everything is cell driven. So just play around with that and you'll see your probability of win. In fact, let me just do a couple of these right now. So let's say they bid 130, the probability of win, I think we might be able to just be able to use this. So about 36%. What if they go to 135? 135, what's the probability of win? So notice that now they're almost 50%. So as we've gone through the discussions this week and we talk about what if analysis, this is exactly what if analysis is all about. What if we bid 135? What about if we bid 140? Our probability wins about 0.65, right? So you can see the value of this. And again, the key being here, make sure that you use cells when you set up all of these equations. Don't use hard values because then you're going to have to go back in there and change everything. What about 145? Right? About 81%. And then obviously if you get to 150, you're going to win it every time because your bid exceeds everybody else's. So a couple more just to kind of get you started here. Hope this is helpful. Have a great week and good luck on that final. And blessings to everyone. Thanks.